All right, let's dive right into this. Welcome to the Explainer that's essentially going to serve as your interactive training course for mastering the absolute core of your daily workflow. I'll be your senior DevOps mentor today, and we are going to walk through the 50 foundational Git commands that you absolutely need to know to survive and thrive in cloud infrastructure. If you've ever felt even a little bit intimidated by version control, grab a coffee, focus in, and let's demystify this whole thing together.
Take a look at this. You're seeing 50 of the most common Git tasks mapped out right here on this massive board of colorful sticky notes. Now, at first glance, a wall of 50 sticky notes probably looks like absolute chaos, right? It can feel like an overwhelming wall of syntax. But don't panic. Today, we're going to break every single one of these notes down. We'll group them, decode them, and actually transform this colorful wall into a highly manageable, logical pipeline that you'll end up using every single day. But before we start typing commands, we really need to understand what Git actually is. Sure, at its core, it's a distributed version control system. But for a DevOps engineer, it is so much more than that. It is literally the essential backbone of infrastructure as code. Think of it as the time machine for your configurations, the single source of truth for your deployments, and the main way you'll collaborate with your team without accidentally overwriting each other's work.
To put this into perspective, just think about where you'll be using this. Whether you're provisioning cloud resources on AWS, deploying application pods to Kubernetes clusters, defining your networks in Terraform, building Docker images, or running massive CI/CD pipelines in Jenkins, Git is where all of that code lives. The rule is simple. If it's code, it goes in Git. Master Git, and you master the gateway to all of these powerful tools.
So here's our roadmap for the journey today. We'll start with the foundation, move into staging and committing, then syncing, remotes, collaboration, undoing and stashing, and finally, the release pipeline.
Let's kick things off with part 1, the DevOps Git Foundation, where we'll look at initializing and branching.
Imagine you've just been assigned to update a brand new microservice. Your very first steps happen right here. If you're starting entirely from scratch, you run git init to initialize a brand new empty repository on your machine. But let's be real, usually the code already exists in the cloud, so you'll run git clone with the repository URL to pull a full copy down to your laptop. Just a quick tip, a common mistake here is cloning into the wrong directory, so always double-check your path first. Once you're in the folder, your absolute best friend is git status. You'll run this constantly. It just tells you the current state of your working directory, what branch you're on, and what files have been changed.
Now, what's really interesting about this slide is how it empowers you to work fearlessly. Branches are basically isolated parallel universes for your code. You can check your existing branches with git branch. When you want to work on a new feature, you just run git checkout -b with your new branch name, and Git instantly switches you over to it. Need to switch back? Just git checkout followed by the branch name. You can rename them with git branch -m, and when you're completely done and the code is safely merged, you clean up your workspace by deleting the old local branch with git branch d. This isolation is huge because it means you can experiment safely on your Terraform scripts without any fear of breaking the main production code.
Moving right along to phase 2, staging and committing changes, or basically locking in your work.
Let's say you just updated a Kubernetes deployment manifest. Git doesn't automatically save this to history. First, you have to stage it using git add followed by the file name, or you can use git add dot to stage all modified files at once. Oh, and if you accidentally stage a secret file, which happens, you can easily unstage it with git restore -- staged. Once staged, you lock it in with git commit -m followed by a clear, descriptive message of what you actually changed. And here is a massive best practice for you. If you realize you made a typo in that commit message right after hitting enter, simply type git commit -amend to modify that very last commit. Seriously, it'll save you from having a messy history full of oops messages. Before you commit, and certainly before you deploy anything, you absolutely must audit your work. DevOps engineers rely heavily on git diff to see exactly which lines of code were added or deleted in the working directory. Then there's git diff/staged to review what is specifically ready to be committed. If you want to view the timeline of all past commits, use git log. And if that gets way too messy and long, git log/online condenses your entire repository history into a beautiful, compact list. Rigorous auditing here is absolutely crucial to prevent major outages later. All right, part 3, syncing remote repositories. This is where we finally connect our local work to the cloud. First things first, you need to know exactly where you're sending your code. By running git remote -v, your terminal will list the exact URLs your local repository is connected to, which is usually called origin. If you're setting up a new project, you can attach your local folder to a cloud server using git remote add origin followed by the URL. Always verify your remotes, folks. You absolutely do not want to accidentally push sensitive infrastructure configuration into a public or totally incorrect repository. So, here is the exact sequence of a daily deployment. First, you run git fetch to download the latest updates from the remote server without actually merging them, just to see what's changed. Then, git pull fetches and merges those latest changes right into your local branch. Now, to send your new Docker configuration up to the cloud for the first time, you type git push -u origin with your branch name. After that initial setup, a simple git push is all you need. When the feature is fully deployed, keep that remote server clean by running git push origin -delete with the branch name. And if you ever need to cleanly sync a feature branch with the latest main code, running git fetch followed by rebasing origin/main is an incredibly professional workflow. That brings us to section 4, collaboration and conflict resolution. Because let's face it, team dynamics can get a bit tricky when everyone's coding at once. When it comes to combining code from two different branches, you have two main choices, merge or rebase. This is a classic debate. Git merge takes a branch and combines it with your current branch, creating a new merge commit. It preserves the history exactly as it chronologically happened, warts and all. Git rebase, on the other hand, temporarily rewinds your commits, pulls in the new changes, and then replays your commits right on top. This creates a perfectly linear, clean history that security auditors absolutely love because it's so easy to read. And remember, if either of these operations goes sideways halfway through, you can always bail out using git merge -abort or git rebase -abort. Now, listen closely, especially if you're newer to this. You will encounter merge conflicts. It happens when you and a teammate edit the exact same line of a deployment file. Git won't guess who is right. It just stops and asks you. Reassuringly, resolving merge conflicts is a totally normal daily task, even during critical production releases. All you have to do is open the conflicting file, manually pick which lines of code you want to keep, delete those ugly Git conflict markers, save it, and commit the resolution. It really is that simple. So don't let conflicts intimidate you. Okay, section 5, undoing mistakes and stashing. So the crucial point here is having safety nets ready for when things inevitably go wrong. Let's look at a real-world scenario. You are halfway through writing this beautifully complex automation script when suddenly a critical P0 production bug hits. You need to switch branches immediately to help fix it, but your current script is half finished and completely broken. You definitely don't want to commit broken code. The solution? Run git stash. This takes all your uncommitted changes and securely hides them away on a clipboard. You switch branches, fix the P0 bug, switch back, and run git stash pop. Boom. Your half-finished work is restored perfectly exactly as you left it. You can manage multiple stashes using git stash list, apply them with git stash apply, or delete old ones with git stash drop. It is an absolute lifesaver. Now, when you actually commit a mistake, you have a few options. Git revert followed by a commit hash is for sure the safest route. It creates a brand new commit that perfectly undoes the changes of the bad commit. It's totally safe for shared branches because it doesn't rewrite or delete history. However, I have to issue a serious mentor's warning here. Git reset -hard physically erases commits and destroys uncommitted changes in your working directory to forcefully roll you back in time. It is literally a nuclear option. Use it with extreme caution. If you just want to undo the commit but keep your file changes locally, git reset -soft head/1 is your gentle alternative. And for simple uncommitted file mistakes, git restore just puts a file back to its last committed state. Finally, we reach section 6, the release pipeline. This is where we look at tags and some advanced ops to get our code out the door. In DevOps, a release is rarely just a standard commit. We mark production-ready code with tags. By running git tag followed by a version number, something like v1.0.4, you create an immutable snapshot of that exact moment in time. You can list all your historical releases anytime with git tag -l. But here's the kicker. Regular pushes don't send tags. You must explicitly run git push-tags. In the modern DevOps world, pushing a tag to the remote server is very often the direct trigger that kicks off your automated deployment pipelines in tools like Jenkins or GitHub Actions. It is quite literally the big green launch button. Just to round out your skills, let's quickly run through some advanced troubleshooting commands. Need just one specific commit from another branch? Use git cherry pick. Someone broke production and you need to find out who? Git blame maps every single line of a file to its last author. To search your commit history for specific text, use git log-grep. Finally, to keep your workspace pristine, git clean-fd aggressively wipes away untracked files, git check ignore helps debug tracking issues, and git config-list verifies your global user settings.
Let's bring this full circle and look at that workflow one more time. This brilliantly illustrates that what initially looked like a chaotic wall of random sticky notes is, in reality, a highly structured, totally repeatable CI/CD workflow. From initializing your repo over in the yellow notes, to staging and committing in the green, syncing your remotes, handling collaboration, utilizing those vital safety nets, and finally cutting that production release tag.
You now possess the 50 commands that form the absolute bedrock of DevOps engineering. It's time to put this into practice. So I'll leave you with this thought. Which of these Git safety nets, whether it's mastering the stash or carefully practicing a hard reset, will you configure first for your very next cloud deployment? Get out there, open up your terminal, and start building. Thanks for joining me on this explainer, and I'll catch you next time.